Welcome back. I see you guys love math so much you just can't stay away from us. It's fabulous. So today we're going to continue our journey through the realm of data and data collection and data presentation with a look at pie or circle graphs, depending on what you want to call them, line graphs, and stem plots. Circle graphs and line graphs you're probably fairly familiar with. Stem plots may be a little bit new, but they're not a big deal. We are going to start with a pie chart, pie graph, circle graph, whatever you want to call it. It's that round thing down there. So I think we will start by doing this. Let's take a look at the grading percentages for the O300 course. We have class participation that counts as 5% of your grade. We have homework and quizzes that count for 20%. We have exams that count for a whopping 50% of your grade. Pay attention to that, folks. It's important. And your final exam counts for 25% of your grade. Now, since we have one big chunk, the 50%, and some others that are relatively small compared to that, a circle graph is perfect for this type of representation because it lets you see how much a certain portion counts toward your grade in picture form. So when we make a circle graph, we know that there are, no, we're going to do it a different way. Take a look at your exams. The exams are 50%, so I want 50% of my circle. This is pretty close to the middle. We're going to estimate. We are not using super precise instruments here. I'm using an iPad and my stylus. So 50% is exams. I am going to color this, but not with the pen. There we go. So that it is color-coded to match my highlighting over on the other side. Okay, now let's look at your final exam. The final exam counts for 25%. Now I know that 25%, if I look at it in money, is 25 cents. I know 25 cents is equal to 1 quarter. That's because 4 quarters make $1. Well, that means 4 quarters of our circle make a whole circle. So I'm going to make what's left of my circle in half. I get 25% for the final. I'm going to make it yellow. For the last quarter of my circle, I have 2 pieces that I need to include in there. I have homework and quizzes for 20%. Class participation is 5%. So I'm going to estimate. I know I need to be smaller than my yellow part because that was 25%. That looks pretty good. So we'll say this is 20% for homework and quizzes. And that part's blue, so I'm going to shade it blue. Totally just shaded the wrong part. I hope you caught that. I was just testing to see if you were paying attention. So there is the correct part, shaded in blue. The last part, our smallest piece, was 5% for class participation. I'm going to color it pink. And because the probability of me being able to write all of that in that tiny little spot is very small, I'm going to make an arrow out here and say 5% in class participation. So you can sit and look at the number percentages all day. But when you look at it in terms of a picture and you can actually see how much of that circle your exam section takes up, I feel like it has a much bigger impact on your understanding of how much those exams are really going to impact your grade. So circle graphs can be very, very powerful ways to represent data. When you want to represent or you want to show the relationship between a certain section of data and its relationship to the whole thing. Let's take a look at some of the properties. These things are really great for comparing parts to the whole. Wrong whole. Like I was just saying, it's great to get across the amount of impact or the actual size of a piece of your data that you want to relate to the whole piece. When you make a circle graph, each section size is proportional to the percentages they represent. But Ms. Graham, we didn't do a proportion. No, we didn't. Here is what that actually means. So we have 360 degrees in a circle. That goes back to high school geometry, middle school geometry, I don't know, 360 degrees in a circle. If we want to figure out exactly how many degrees we need to take up on our circle, we know that the percent over 100 is the number of degrees for our section over 360 degrees total. So we can use it. Let's say we want to know how many degrees our exam section should take up. So I'll put it down here, exam section. It was 50%. So I would put 50% or 50 over 100. Let's use D for degrees. Now you guys have already solved proportions. This is not new. So we're going to cross multiply. I'm going to pull out my handy dandy calculator over here because you don't want me to do that in my head. 50 times 360 is 18,000. I'm going to multiply the other way. And I want d by itself, so I'm going to divide by 100. That tells me that I need 180 degrees of that circle for my 50% of exams. Well, it just so happens that 180 degrees is half a circle, or 50% of the circle. So that's how I knew to take up half the circle. If we wanted to take a look at that 5%, see how many degrees are in that 5%. So if we do class participation, we know it's 5%. Our formula said we should do 5 over 100 is the number of degrees over 360. Well, we know that 5 times 360 is 1,800. 5 is missing a 0 from the 50, so I can do 360 times 50 and just take off a 0. If I multiply the other way, I get 100d. Divide by 100. So I get d is equal to 18 degrees. So theoretically, if I had pulled out a protractor and all of the fancy circle making things, this would be 18 degrees of my circle. Homework and quizzes. There we go. Took up 20%. So I would do 20 over 100 is degrees over 360. That means 100d should be 7,200, but we're going to double check. Because my mental math is more than slightly lacking. If I divide by 100, it tells me that this piece in here should be 72 degrees, if we wanted to draw it accurately. For that last piece, we could do the similar process with a 25. It would be half of the 50%. So this would actually be 90 degrees right here. So it's probably more than you ever wanted to know about a circle graph. You're welcome. Let's go look at interpreting a circle graph. So Joelle has kept track of everything she does during the day. Maybe she wants to look at whether or not she's wasting time. So she wants a picture of what she spends most of her time doing. Well, if we look at number 1, it says, what single activity does Joelle spend most of her time doing? That is super easy to get from a circle graph because we just look for the biggest chunk. And it looks like the biggest chunk of this circle graph comes from this 36% sleeping. So she spends 36% of her day, that's the largest chunk, sleeping. 2 says, does she spend more time doing school-related activities or sleeping? Well, we already know that sleeping was 36%. So we need to go find the school-related activities and add up their percentages to see which one is bigger. So let's take a look at some school-related activities. Definitely, we have the big school right there. Technically, homework is a school-related activity. So we already have 27% and 11%. We could count the bus ride to and from school as a school-related activity. Now, we don't know if play rehearsal or eating or reading are necessarily happening in relationship to school. So we can stop there. I think it will give us what we need. 27 plus 11 is 38, and 4 is 42. So it looks like Joelle spends 42% of her time doing things related to school, 36% of her time sleeping. So definitely spends more time on school-related activities. How many hours per day does Joelle spend doing homework? Be very, very careful, because the tendency here is to go look at the homework lesson, the homework section, and say, oh, she spends 11 hours. No, that is not what that means. This means Joelle spends 11% of the whole day doing homework. Well, we know that there are 24 hours in one day. So we could say she spends 11% of, not of 24 hours doing homework. Now, we just did this in Unit 3. So we can reword this into a question that fits the is over of pattern that we looked at. So we can say 11% of 24 is what? So I put my is over of and my percent over 100, cross multiply, I think that's 264. If I divide by 100, I get 2.64 hours. Now, it doesn't tell me hours and minutes, it just says how many hours, so we can leave it as 2.64. Let's go take a look at a line graph. You guys have been making line graphs for a while. They are very much like a bar graph, but we don't use a rectangle, we just use a dot, and then we play connect the dots. When you make a line graph, there are some parts of your graph you need to be aware of. We do have, let's do it this way. You do have what we typically call the x-axis. That's this guy. If you're not calling it the x-axis, it would be called the independent axis. Where we house our independent variables, weight, not weight. I had a brain spasm. Horizontal axis is things like month. A lot of the times, this is going to be time, especially with a line graph. The y-axis is the vertical axis. Remember, vertical goes up and down. This is typically, in algebraic terms, we call this the y-axis. We also call it the dependent axis. This would be for weight or height, perhaps cost. In this case, we are going to use weight. When you make a line graph, we need to make sure people know what they're looking at. So make sure you label your axes. So we'll do, what are we measuring in? We're measuring weight in pounds. And then across the bottom, we are doing time. So we can do months. If we go look at our graph, we are graphing Bailey the puppy's weight. The weight, that was interesting. Let's see if we can make it more of a circle. Much better. So the weight is our dependent variable because her weight depends on how old she is. And we will put the month along the independent axis. They started tracking her weight in April. So we will make the very beginning April. And then May. June. July. And August. I think our scale going vertically will be pretty safe if we just count by ones. So this would be 1, 2, 3, 4, 5, 6, 7, 8. We don't have to number all of them as long as our boxes are exactly the same size. So in April, Bailey weighed 1 pound. In May, she only weighed 1 pound. In June, she doubled her weight, so she moved up to 2 pounds. July, she hit a growth spurt and weighed 5 pounds. In August, she weighed 8 pounds. Now, with a line graph, we need a line. So we go and we connect our dots. Now, we don't want to make them smooth. We want to actually connect them with straight lines. Why is this important? Why is this useful? Well, a line graph is really good for showing a trend over time. When you were very small, your doctor had a graph of your height versus your age, and they tracked your growth that way. So it showed them how fast or how slowly you were growing. The stock market. is also a place where line graphs are hugely useful because investors want to see what that stock or how that stock is performed over the course of several years before they go and invest in it. It makes it really easy to see whether the variables are growing faster, whether they're decreasing. So it's super useful for comparing those things. Remember the X or the independent axis is the horizontal axis. The Y or the dependent axis is the vertical axis. When you do a line graph, typically the x-axis is probably going to be some type of time. It could be in months, it could be in years, it could be in days, but most of the time it's going to be time. Stay tuned. In the next video, we'll give you a rundown of what a stem plot looks like. See you soon.